Okay, you better have read that example. It was about the price of a truck and different kind of trucks and getting a scatter plot for the price of trucks and how much mileage was on them. And it's a fairly interesting example, really. Anyway, the next definition, extrapolation. There's a new math word for you. Extrapolation is a bad idea. It's the use of a regression line. What do I mean by a regression line? The thing we just did on the last page, the y hat equals a plus bx, to predict values from a scatter plot for values of x. But we're using x that are well outside of the range of data of the original set. That's a bad idea. Why? Because you have no guarantee that the form of the scatter plot is the same for different values of x that are that far away. Maybe the scatter plot looks linear with the x's that you got, but if you go down the road, down the x-axis, and pick different x's that aren't anywhere near the x's you got, maybe the form isn't the same. So our regression line from the original scatter plot was y hat equals 20.6 plus 0.22x. That was about gas mileage and speed, right? Predict the gas mileage while you're driving down the road at 180 miles per hour. Yep, you get out on 88 and you're just trying to get past Naperville, so you're just going to go 180 miles per hour on your way into the city. Let's make a prediction for what kind of gas mileage you're probably getting. Okay, so that's y hat is equal to 20.6 plus 0.22 times 180, probably already been pulled over by a cop, is equal to 60.2 miles per gallon. If you know anything about cars, there's no way that when you're driving 180 miles per hour, the car is operating at 60.2 miles per gallon. That doesn't seem right. Why? Because the relationship that we had in this scatter plot, I'm going to bring it back for you just a second. Sorry about this. That relationship right there, it actually looks like it's kind of curving anyway, doesn't it? Like it's leveling off. But we're using a line that just keeps on going straight. Straight, straight, straight. By the time you get all the way out to 180, we're way up here. We're predicting that gas mileage. And look at where this is going. There's no way that's true. So that's an example of this word extrapolation. It's a bad idea to make predictions for x's that are well outside your data range. And that 180 is well outside our data range. This doesn't make any sense at all. Okay, so here we go, finishing off this page. Studying the particulars about a scatter plot and a regression line. The data points usually aren't even on the line. It's a scatter plot. They scatter. We're sending the line through a bunch of dots because scatter plots tend to scatter. There you go. So one thing we study in a scatter plot is the set of residuals. There's another new word for you. The residuals that result from a regression line. So let me throw a definition at you. A residual is the vertical distance between an actual value of y. So I'm going to actually write y in the parentheses. That might look stupid, but give me a second. And a predicted value for y. Now that one's a y hat. So this actually comes from an actual data point, xy, but this one comes from the y hat equals a plus bx. It's not an actual data value, it's something we get from our equation for a given x value. Okay, so here's your big formula. There's your big crazy math formula. You ready for this? Every time I ask you to calculate a residual, you go take the actual data value y and you subtract what we get when we put that same x in for the equation. So visually, let me give you a visual for what that means. Ready? So here's my scatter plot. I got my scatter plot. There's my dots. Got my scatter plot. And then I make my line of best fit, right? There's my y hat equals a plus bx. That's my line. Now this is an xy point that's an actual data value. I'm going to go down and I'm going to hit this x right here. See what I mean? Now if I take that x and I look it up in the data, I'm going to find out that's the y that went with it. But if I take that x and I put it in this equation, I'm going to get a y hat. Where's it going to be? It's going to be right on this line, isn't it? That's the point x, y hat. Okay, so when I'm referring to this residual in this distance, look, it's this distance right here. It's that vertical distance right there. How far away from the line is that point in a vertical direction? That's what I'm talking about with a residual. All right, next page.